Okay, in this question, you're given a car with area and a drag coefficient of 0.32 when the windows and sunroof close, and the drag coefficient increase to 0.41 when the sunroof is open. Determine the additional power consumption of the car when the sunroof is open at 55 km per hour and 110 km per hour. Take the density of air to be 1.2 kg over meter cube. Okay, so again for this one, you calculate the drag force is equals to drag coefficient times rho v squared over 2 times A, and then power from drag, okay, is equals to drag force times velocity, and additional power we will find to be P open minus P close. Okay, then A is given to be 1.7 meter square. Density is 1.2 kilogram over meter cube. Close sunroof drag coefficient equals to 0.32, and then the drag coefficient open sunroof is equals to 0.41. Okay, and then we want to find for V is equals to 55 km per hour, which is equals to 15.28 meter per second. So we find drag force is equals to 0.32 times 1.2 times 15.28 square divided by 2, okay, times 1.7. So this is equals to 76.2 kilo Newton. 76.2 Newton. Okay, and then the power you use when the sunroof is closed is equals to 76.2 times the velocity, which is 15.28 meter per second, and this is equals to 1.16 kilowatt. Okay, this is when it's closed. Okay, when you open, the drag force become 0.41 times 1.2 times 15.28 square divided by 2 times 1.7. So you get 97.6 Newton, and the power when open is equals to 1.97.6 times with the speed, which is 15.28, and this is 1.49 kilowatt. Okay, so the extra power consumption is equals to 1.49 minus 1.16. This is 0.33 kilowatt. Okay, so that is for the first velocity. Okay, for V is equals to 110 km per hour. This is equals to 30.56 meter per second. Okay, and again you find the drag force with closed windows. 0.32 times 1.2 times 30.56 square divided by 2 times 1.7. So this is 304.7 Newton. And then the power when closed is equals to 304.7 times 30.56 equals to 9.31 kilowatt. Okay, when you open the windows, you find the drag force is equals to 0.41 times 1.2 times 30.56 square divided by 2 times 1.7. This is equals to 390.5 Newton, and the power consumption is 390.5 times the velocity 30.56, which is equals to 11.93 kilowatt. So the increase in power consumption is 11.93 minus 9.31 equals to 2.62 kilowatt. So the additional power is 2.62 kilowatt at 110 km per hour and 0.33 kilowatt at 50 km per hour, 55 km per hour.